right, so horizontal versus vertical. You're going to hear me a lot say things are moving horizontally, things are moving vertically. It's important to understand what horizontal and vertical mean. Horizontal is left to right, vertical is up and down. So the point 6, 4 is moved horizontally 6 units to the right and vertically 4 units up. So the idea is that we are going to talk a lot about transformations of graphs. We're going to talk about graphing transformations in this chapter as well as chapter 5. So it's kind of one of those concepts that we're going to learn, come back to, and learn some more. Graphing an absolute value, the parent function is y equals absolute value x. So what we're going to do is apply transformations to this parent function. So what I want to do is just start by plotting some points so that we can get that extra practice in. Because I noticed when we were making our tables that one of our issues was not knowing how to plot the points we got in our table. So 3, 5 is in quadrant 1. Negative 2, 7 is in quadrant 2. Negative 6, positive 4 is also in quadrant 2. 0, negative 5 is in quadrant none because it's on our axis. 0, negative 5 is kind of like a y-intercept. 3, 0, conversely, would be like an x-intercept. Negative 3, negative 6 is in quadrant 3. Negative 6, negative 5 is also down there. 2, 7 jumps back up to quadrant 1. It's symmetric with point B, meaning they're both up 7, but one's right 2, the other is left 2. I is at 7, 0. J is at negative 5, positive 4. And then K is at 3, 6. L is at 5, 3. M is at 0, 6. And N is at negative 7, 0. So previously we've talked about absolute values, we talked about solving absolute values. Today we're going to talk about graphing absolute values. All absolute value functions graph as a V. All absolute value functions graph as a V. The highest or lowest point is known as the vertex. The highest or lowest point is known as the vertex. All absolute value graphs can be folded in half. They have mirror images on the right and the left. All absolute value graphs can be folded in half down the AOS, or the axis of symmetry. They can be folded in half. It does. So the reason we learn absolute value graphs after piecewise Or because absolute values are actually piecewise functions. Absolute values are actually piecewise functions. So there are some characteristics of absolute value functions. The first characteristic is that the vertex is at 0, 0. So absolute value functions have characteristics. Characteristic number 1 is that the vertex of the parent function is at 0, 0. The axis of symmetry is through the vertex at x equals 0. The slope is 1 to 1. Our domain is all reals. And my range is all real. So these are those bullet points on your paper. So the vertex, it is important to note the vertex is at 0, 0. So it starts at the origin. It's going to start at the origin for all graphs today. The slope of the graph goes up one and right one. It's going up one, right one, up one, right one, up one, right one. But because we can fold that graph in half through that dashed green line, it also goes up one, left one, up one, left one, up one, left one. So the slope goes to the right and to the left, the same steepness. All absolute value graphs have domains, all reals. All absolute value graphs have domains, all reals. What's the domain of an absolute value graph? All reals. The range relates to the vertex. We're going to talk more in depth about that over the next few days. Okay, when graphing an absolute value function, there are a couple basic transformations. When graphing an absolute value function, the first basic transformation comes from the A value. The A value is going to tell you if it is stretched or compressed. This is going down in that blank space at the bottom. You got to write it all out. So the vertex is always going to be H, K. That is the most important thing to remember because the vertex is always going to be where we start our graph. The vertex is always going to be H, K. It is very important to remember because it is where we start our graph. A negative in front of the A value will reflect the graph. It will make it open down like a frown. A negative will make it reflect or open down like a frown. So if you are a negative person, then you are probably frowning.
Are you frowning?
What would you like to know? An A is going to stretch or compress your graph. The A is going to stretch or compress your graph. So, think about stretching something in general. If you were to stretch yourself as a person, you're going to become more narrow. It's harder.
You're narrow too, Mr.
If you were going to compress yourself. So So if you took your height and your weight exactly as you are now and you made yourself 6 inches shorter, but you didn't lose any weight, what direction are you going to go? You're going to go all wide. That is the same with a graph. If you stretch it, it's going to come narrow. If you compress it, it's going to get wide. So today, we are only focusing on the A values. We're only focusing on reflecting, stretching, and compressing. When A is positive, I already said it, the graph opens up. When A is negative, the graph opens down. Positive A opens up, negative A opens down. Okay. We discussed it. Now let's put it into words. If a graph is stretched, my A value is going to be greater than 1. My graph is going to be narrow. If it is compressed, my A is between 0 and 1, and my graph is going to be wider. Everybody okay? Alright, so let's graph our example. We have 1/2 and it is negative. So we have negative 1/2 x. A negative in front of my graph is going to reflect it. So instead of opening up, it opens down. That negative 1/2 is like my slope. For today, every vertex of every absolute value is at 0, 0. For today, all vertexes of all absolute values are at 0, 0. It's going to change tomorrow, but for your homework tonight and for in class today, all vertexes are going to be at 0, 0. A slope of negative 1/2 is going to reflect my graph down and compress it. So it's reflected and compressed. It's going to go down 1 and over 2, just like the slope of a normal line would. But remember that every point is symmetric. So if it goes down 1 and right 2, It's also going to go down 1 and left 2. Connect your dots. And you're done. What's the domain of an absolute value? All real. Now the range of this one would be flipped from the other range, right? So this graph is open down. So this range would be all y values less than or equal to 0. So it's up and down, round, and my y's are negative. Okay. Y equals the absolute value multiplied by 4. So that 4 out in front is going to do what to my graph? Going to what? Yeah, more narrow. It's going to stretch it up. So it's stretched. It starts at 0, 0. That 4 represents my slope. So it goes up 4, right 1. It goes up 4 and right 1. It also goes up 4 and left 1. From that point, it goes up 4, right 1. From this point, up 4, left 1. All absolute values have arrows pointing in whatever direction the line is going. Thus, my range is continuous. What's my domain? All real. If you want to say it's y greater than or equal to 0. Okay. Here, my equation is y equals 1/4 x. So that 1/4 is going to compress it. So it's going to be wider. The purple graph is the parent function. So you can see that it is wider than the parent. My slope is up 1 over 4, up 1, left 4. Domain is all reals. And range is y values greater than or equal. Without graphing the last one, is y equals 3 as absolute value going to be stretched or compressed? Is 3 halves going to make it stretched? Because 3 halves is greater than 1. Okay. So once again, domain is all reals, range is all reals. My graph is stretched. You can see it's inside the parent function, making it more narrow. Let me mark down your phone. Yes, your homework is the front and the back of the next page.
Okay, watch your dad. Watch your dad. Okay, go.
Hands off. Sit down.
What is that?
Okay, remember guys, calculators away. Get your phones and have a seat till the bell rings. Calculators away, get your phone and have a seat till the bell rings.